So a question that comes up from a lot of people is, how is it okay that CNN and Gallup and news organizations, they poll, 1,000 people in the whole country, and then they claim to know how it's working, or for example, if I take us back to this polling center here, you can see they polled 770 voters in Florida. How is 770 enough? Like, how is that fair? Or 741 here in Ohio. How is that okay? And the answer is, well, as long as they do it in a good way, it should be fine. So when you're sick and you go to the doctors to find out what's wrong, how much blood do they need to draw? Do they need to take all of your blood? No, I mean, I would hope not, right? They only need a sample of your blood. So we only need a nice, fair, random, unbiased, independent sample, right? As long as we have that, which in a doctor's office isn't hard to come by, it's just a vial of your blood. But for polling, as long as we satisfy that, as long as we have it fair, balanced, unbiased, random, all that good stuff, then we should be okay, right? It should do a good job of estimating the population proportion. But you can't just go out and start calling people and calling people and calling people till you get what you want. You have to decide ahead of time how much error you're going to live with, and then that'll give you a clue to how many people you need to call. I mean, this stuff needs to get set up ahead of time. Somebody has to be told, like, okay, you need to call people until you hit 750 or whatever. So they're not going to keep calling and calling and calling. They want to keep calling till they reach their number, and then they want to stop and go home for the day, right? So how did they decide ahead of time to call 740? How did they decide to call 770? How do they decide for this one to call 1,238? How do they make that decision? Well, you take p times 1 minus p times z alpha over 2 over your error and squared. Or and this one is if you have a prior estimate. Like, let's say they did a poll last week for Florida, which they did. So if they did a poll last week for Florida, they don't need as many people this week for Florida because they just did another poll. Right? So if you have a prior estimate, if you have, another poll from another week or another year, then you can kind of put the numbers you had from that other week or other year in there for p hat. All right, if you don't have a guess or you just have no idea what it's going to be, or let's say it's really, really close, like in a lot of these states, it's so close to 50-50, they're better off with higher numbers, so let's put in 50-50. So if you want to do that, what's 50.5 times 1 minus 50, 1 minus 0.5? 0.5 times 0.5 makes 0.25, and that's where this formula comes from. So if you have no prior estimate or you think it's just too close to call and it's 50-50, then you're going to use this bottom one right here. All right, so suppose we want to know how many students we need to poll to find out whether statistics professors at JCC are awesome. How many people are we going to need to poll if we want 95% confidence with a 4% margin of error? Well, it's important to notice for this particular problem that we have no prior experience for what P is. We weren't told, like last year they did a poll and it was 75% of people think they're awesome. We didn't get any of that. So since we don't have that, we don't have a prior estimate, which means we're stuck using the 0.25 formula. Sorry, I'm going to make this bold right here. Okay, so let's see here. We're going to be using this 0.25 one, which is this formula right here, z alpha over 2 over the error squared. So that's 0.25. Now, the 1.96, where does that come from? Well, it comes from the fact that this was 95% confidence. And we said way back here, we found it with Excel right there. 95% confidence for a z-score is 1.96. So there we go, back. Okay, so we put 1.96 there, and it said 4% margin of error. So you always have to change that to a decimal to make it 0.04. And they mention it right here. The margin of error should always be expressed as a decimal. See right there? Last sentence in the little blue box. All right, so you take Excel, take a calculator, take whatever. You type this up, and you find the answer is 600.25. Well, you can't poll 0.25 of a person. That's not going to work. So you must always round up. See the up right there? You have to round up, no matter what. Right? Round up. All right, so we're going to round that up to 601, and that's our final answer. So we would have to poll 601 JCC students to find out what they feel about whether or not teachers at stats professors at JCC are awesome. All right, now how would that affect us? We better make a note to ourselves. Note, round up, no matter what. All right, now what would happen if I want a 95% confidence again, but with a 3% margin of error? So what am I doing from problem to problem? So A was 95% with 4% margin of error. This one's with 3% margin of error. Same problem though. So we still don't have a prior estimate, so we're going to use the same idea. It's just that bottom number is going to turn into 0.03 this time. And you can use Excel or a calculator, but you'll find that it's 1067.1, which is about 1068. There we go. Okay, now what happened there? Look what happened. We shrunk our error. Now remember, error is the distance, here's a picture. Error is the distance from the outer edge of the interval to the center. It's directly related to how big your interval is. Right? The larger your error, the more wiggle you have, the sloppier your interval is going to be, the larger your interval is going to be. So more error makes a larger interval. So when we do that, when we have more error, or less error, that means that we're going to get more people. So if you want to get a smaller error, if you want to get a more accurate interval, then you're going to need to go get more people, right? You don't want 4% margin of error. 4% is too much wiggle back and forth. You want only 3%. Well, then you're going to need to get more people. And that's what this says here. If the sample size increases, then the margin of error decreases. That's an example of an inverse relationship. We learned it in chapter 4, right? Inverse. Now, if you don't believe me, let's just go back and look at CNN for a second here. Look at this. North Carolina right here. North Carolina had a poll of 1,238 voters. The margin of error was 2.79%. If I look right over here at the Florida poll, they only had 770 voters. And look at that margin of error. Much larger, right? So the larger your error, the smaller your sample size. The smaller your error, the larger your sample size, right? Error is not necessarily a good thing. We generally don't want it to be very large, right? Because error is how much up or down these two values are, right? So it's not really 45%. It's really 45 plus 2.79 and 45 minus 2.79. That's kind of messy, right? So we want them to be more accurate, so we go get more people. All right. Now, what would happen if we change our confidence level? So I'm sticking with the 3% like we had before, but I'm going to change it to a 99% confidence. Okay, well, if it's 99%, that's going to change the number right here at the top. It's not 1.96 anymore. We can scroll back and find where we found it before. Oops, there it is. It was 2.576. So just put 2.576 in here. And then you use your computer or whatever to find that number. Here, I can type it up just in case you're curious. It would be equal to 0.25 times parentheses 1 or 2.576 divided by 0.03 close parentheses, square it. So you get 1843.27. Oops, I'm on this one. So 1843.27, which would be 1844. Got to round up no matter what. Okay, now look what happened. We kept the same margin of error, so the width of the interval is going to be the same because your margin of error is the same, but I'm more certain that I caught it in there. Well, to do that, if the sample size increases, then the confidence level increases. Right? In other words, there's a direct relationship here. If you boost your confidence level, if you want to boost your confidence level but keep your margin of error, then you're going to need to get a larger sample. Right? Now, suppose instead of having, flying blind here, suppose we actually had some prior data. We knew that last year, 67% of students thought that JCC professors were awesome. Okay, so I wanted 99%. I still want 3% margin of error. So it's the same formula as the one we just did. It's just that in the front, instead of 0.25, I'm going to need p hat times 1 minus p hat. Okay, well, p hat from before was 0.67 times, and then I need 1 minus 0.67. And then you keep the 2.576 because it's still 99%. And you keep the 0.03 because it's still 3% margin of error. And then you should find that it's 1631, I think. Let's double check that. I can just go in here to Excel. And again, you don't need Excel on this. It's just, I'm just using it as a glorified calculator here. 0.67 times parentheses 1 minus 0.67 close parentheses times 2.576 over 0.03 all squared, and I get 1630.1. Right, so 1630.19, which is 1631, because you can't, of course, pull 0.19 of a person or whatever it was. Cool. Well, I better save this. I don't want to lose this file. You know, chapter 9, technology. Cool. And again, you don't have to have these two particular calculations in there. It's fine. Have them or don't have them. It's all good. All right, now what do we notice here? When we didn't change the error, and we didn't change the confidence level, but we had a prior estimate, right? Having a prior estimate means what? Means you need smaller samples, right? So if you have a prior estimate from past data, you won't need to poll as many people, i.e. you won't, you will need a smaller sample. Or here, you won't need as large a sample, let's put it that way. Won't need as large a sample. If you have no prior estimate, then you're clueless, and when you're flying blind, you're going to have to go get bigger samples to try to get a sense of where things are. But when you have a prior estimate, you can get away with a smaller sample because you have that prior data.